This video is on Unit 2, Chapter 5, Solving Quadratic Functions, Lesson number 3, Solving Quadratics using the Quadratic Formula. In your notes here, it has a reminder for you what the Quadratic Formula is. X equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. And in the notes here, it says step number 1 is to write the equation in standard form. Ax squared plus bx plus c is equal to 0. So you do need a 0 on one side here. You want to identify the a, the b, and the c, and then substitute them into the formula and then simplify. So we're going to start with example number 1. In example number 1, we've got x squared plus 2x minus 63 is equal to 0. We already have a 0. So I'm going to go ahead and identify A, B, and C. A is always the coefficient on x squared. So in this instance, A is equal to 1. B is always the coefficient on the x, the linear term, which in this case is a 2. And then the C is always your constant, your plain number, so negative 63. We're going to take this and we're going to plug it into the quadratic formula. X equals the opposite of b. Now, a lot of teachers teach this by negative b. I like to use the word opposite b so that when y'all plug this into the formula, you look at the b that you have and you change its sign. Plus or minus the square root of b squared, please use parentheses, minus 4 times a times c is negative 63. All of that is being divided by 2 times a. Now, side note here, the b squared minus 4ac part of the quadratic formula is called the discriminant. Now, the discriminant can give us a hint about what kind of solutions we have. If you calculate the discriminant and it is a positive perfect square, then you have 2 real rational solutions. I don't have room for solutions, but solutions. If it is just a plain positive number, I'll say non-perfect square. You're still going to have 2 real solutions, but they're going to be irrational. If your discriminant is 0, it's equal to 0, then you're going to have 1 real rational solution. And if your discriminant is a negative number, then you're going to have 2 complex solutions, which is your A plus B I. Now, I will also say this. If your discriminant is negative and it is a perfect square, then you're not going to have a radical in that complex solution. If it's a non-perfect square, it's going to combine i's and radicals. So let's look at going back to example number 1 and find the discriminant. So I'm going to do the 2 squared minus 4 times 1 times negative 63. And I'm just going to use my calculator. 2 squared minus 4 times 1 times negative 63. And I get 256. So I'm going to rewrite this as negative 2 plus or minus the square root of 256 over 2 times 1 is 2. Now the question is 256 a perfect square? So if I take the square root of 256, I'm going to get 16. So my discriminant is a perfect square. It's positive and it's a perfect square. So I'm going to have two real rational solutions. So I'm going to rewrite this again as negative 2 plus or minus the square root of 256 was 16 divided by 2. Now, how do I find what those two real rational solutions are? There is a plus and a minus in the middle of this formula, which means that my two solutions can be found by one using the plus and then the minus. So we're going to calculate both of these. Negative 2 plus 16 is 14, and 14 divided by 2 gives me 7. And then negative 2 minus 16 is negative 18, and negative 18 divided by 2 is a negative 9. So my two solutions for number 1 are a negative 9 and a positive 7. We're going to look at example number 3. I've got negative x squared plus 2x is equal to 1. I'm going to subtract that 1 to get my 0. Again, that's very important that you have a 0 on one side. Identify the A, the B, and the C. A is a negative 1, B is a 2, and C is negative 1. And then we're going to plug this into the quadratic formula. X equals the opposite of B plus or minus the square root B squared minus 4 times A times C, all divided by 2 times A. So now I'm going to find my discriminant for number 3 by plugging in the 2 squared minus 4 times negative 1 times negative 1. And most of us can probably do that in our head, but I'm going to go ahead and do it here in the calculator. And we should get 0, which we did. So when my discriminant is equal to 0, what I just told you is that tells us that we have one real rational solution. And y'all, what that means is this parabola is only hitting the x-axis one time. So back on example number 1, the parabola hit the x-axis at negative 9 and a positive 7. But in number 3, it's only going to hit at one spot. So to find that one spot, and most kids are going to go ahead and put a 0 here, or the square root of 0. Well, let's talk about that. What is the square root of 0? It's just 0. And if I add a 0, nothing happens. And if I subtract a 0, nothing happens. So this part of the quadratic formula goes away, which is why we only have the one solution, which is 1 in this instance. It only creates one solution because the plus and the minus is what would create two solutions, but it's going to go away. All right, let's jump down and look at number 5. 9x squared minus 1 equals 24. I need a 0 on one side. So I'm going to subtract the 24 from that negative 1. And we get 9x squared minus 25 equals 0. So for this one, 9x squared minus 25 equals 0, there is no bx. I'm going to show you quadratic formula because that's the lesson that we're on. But if I were working this problem, I would not use the quadratic formula. You could solve this one by factoring. And then there's also another method that I'm going to teach you later on in this chapter that would actually be even easier. But I'm going to show you quadratic formula for right now. Ax squared, so A is 9. There is no B, so I'm going to substitute a 0. And C is negative 25. Plugging this into the quadratic formula, x equals the opposite of b, well, the opposite of 0 is still 0, plus or minus the square root of b squared minus 4 times a times c, divided by 2 times a. So your discriminant is 0 squared. And I'm going to go ahead and do it because I know y'all will. 0 squared minus, actually, 0 squared minus 4 times a times c, which gives us 900. 900. So I have 0 plus or minus the square root of 900 all over 2 times 9 is 18. So on this one, the 0 that's out front, once again, is not necessary. But the plus and the minus are. Plus and the minus are in front of the radical. So the plus and the minus have to stay. And then the next question is 900 a perfect square? Yes, it is. So again, what that tells me is my discriminant is positive and it's a perfect square. So I should have 2 real rational solutions. The square root of 900 is 30. So this gives me a positive and a negative 30 over 18. Now the last step here is to just simplify your fraction 30 over 18. 30 over 18, 6 goes into both. So I have a positive and a negative 5/3. And those are my 2 solutions. All right, we're going to look at example number 7. Looking at example number 7, I have x squared minus 9x is equal to 4x. We're going to subtract the 4x. Now be careful on this one. When you subtract 4x from both sides, we do get our 0 on the right. There's nothing to subtract 4x from, and we want to make sure that we put this in standard form. So x squared minus 4x minus 9 is equal to 0. From here, identify your A, your B, and your C. And then plug it into your quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So again, I'm going to calculate that discriminant, just the B squared minus 4AC part. So negative 4 squared minus 4 times 1 times negative 9. And I get a positive 52. Positive 52. All right, now what does that tell me? It's positive, so my answers are real, but is 52 a perfect square? No, it is not. So what that tells me, if we go back to my notes on that, when it's a non-perfect square, I'm going to have 2 real solutions, but they are going to be irrational. Now, irrational solutions are going to have a radical left in your answer. So what we have to do at this point is we have to simplify the square root of 52. And you're using whatever method that you got comfortable with back in chapter 4. So when we simplify the square root of 52, it is a 4 times 13. So I have 4 plus or minus. The square root of 4 is 2 times the square root of 13 over 2. And I'm still not done. So you've seen this before in a different lesson, but these 3 spots right here, if they have a common factor, you have to factor it out. So a 4, a 2, and a 2 have a common factor of 2. We're going to divide that out. 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1. I'm not going to put the 1 in front of my radical. And then in the denominator, 2 divided by 2 is also a 1. So basically my denominator goes away. And there are your 2 solutions. Now you might see these written 2 plus radical 13 and 2 minus radical 13. But those are your solutions. Okay? Again, there is a radical in the answer because you have irrational solutions. let's jump down to number 11. In number 11, I have negative 3x squared plus 8x minus 7 equals 0. So I already have an equals 0. I'm going to label my A, B, and C. A is negative 3, B is 8, and C is negative 7. So we're going to plug that into the quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And that's a 3. Doesn't look like a 3, but it's a 3. Once again, I'm only going to calculate the discriminant in the calculator to figure out what kind of solutions I'm going to have. So 8 squared minus 4 times negative 3 times negative 7. And I get negative 20. So what does that tell me? Well, because I have a negative under the radical, what that tells me is my solutions are imaginary. And the 20 is not a perfect square. So I'm also going to have a radical in my answer. So here we go. We need to first simplify the square root of negative 20. So just like we did back in chapter 4, we know that the negative that's under the radical immediately means that there's an I on the outside. The 20, because it's a non-perfect square, also automatically tells me that there's going to be a radical left. So again, you're going to simplify this radical using whatever method you prefer. I'm going to break 20 down into 4 times 5, which is going to give me 2i radical 5 in the top, and then of course my negative 6 in the bottom. Just like I did on the last question, we're going to look at the negative 8, the positive 2, and the negative 6. Is there anything that will divide evenly into all 3 terms? Yes, there is. It's a 2. I'm going to use negative 2 because I never, ever, ever want you to leave a negative in the denominator. So divide each of those by a negative 2. Negative 8 divided by negative 2 is a positive 4. Plus or minus 2 divided by 2 divided by negative 2 is a negative 1i radical 5. Now what you're going to notice is I don't put a negative right next to that I, and here's why. There is a plus and a minus in front of the I. So the I is already negative. I don't need another negative to tell me that. And then negative 6 in the denominator divided by negative 2 gives me a positive 3. So there is my answer for number 11. And again, you might see that answer written out with both the plus and the minus. So you might see it written either way. The last one that I want to do is number 12. I've got 5x squared plus 9 equals, that's an equal sign, 4x plus 5. So for this one, I need to subtract the 4x and I need to subtract the 5. So when I subtract the 4x, I'm just going to get a negative 4x on the left, and then 9 minus 5 is a positive 4. So we have 5x squared minus 4x plus 4. A is equal to 5, B is equal to negative 4, and C is equal to positive 4. So once again, all we're going to do at this point is plug this into our quadratic formula. X equals opposite B plus or minus square root of B squared. Please make sure you use a parentheses. Minus 4 times A times C, all divided by 2 times A. And just like every other problem that I've done, I'm going to find my discriminant. So negative 4 squared minus 4 times 5 times 4. And I get a negative 64. So again, negative means I have an I in my answer. But the 64 is a perfect square. So what that tells me is I don't have a radical in my answer. So let's see what this looks like. The square root of negative 64 is an 8i. So that reduces into 4 plus or minus 8i over 10. And again, you're going to focus in on the 4 and the 8 and the 10. And is there any number that will divide evenly into all of them? 2 divide evenly. 4 divided by 2 is 2. 8 divided by 2 is 4. And 10 divided by 2 is 5. And there's your solution for number 12. So to wrap this up in a nice pretty bow, when you're solving quadratics using the quadratic formula, it always works. No matter what, it will always work. Sometimes your answers have an I, like number 12. Sometimes your answers have an I and a radical, like number 11. So those are complex solutions created by that negative that's underneath that radical. Sometimes we have irrational solutions, like on number 7. So the discriminant here ended up being a non-perfect square, giving us those irrational solutions. They're still real, but they're irrational. And then sometimes we have nice, pretty answers, like question number 1, because your discriminant was a perfect square. It's positive, it's a perfect square, 2 real rational solutions. And then, of course, if your discriminant is equal to 0, you have the 1 solution. So that wraps up your notes for Chapter 5, lesson number 3 on solving using the quadratic formula.